Hey, g'day, it's Prezzo. Thanks for stopping by. Now I'm starting a new project today. It's a collaboration with another YouTuber named Mark Winquist. Now he goes by the name Winky's Workshop. He lives in Kentucky in the USA and he's into restoration of old machinery. His background is working in the printing industry and I love the work that he does. He does it with a great deal of integrity and the finished projects are always beautifully finished. So he got in touch with me a while ago and we were talking about the process of parting off stock in the metal lathe. And it's a topic that I visited some time ago and I thought it was worth pursuing. But let's have a closer look at what's on the bench here and I'll try to explain where this is going. Now when Mark got in touch with me, he asked what style of quick change tool holders I used on my lathe. Now these are BXA style. Mark's lathe is a bit smaller than mine and he uses the AXA style, which is slightly smaller. Now he asked if I was interested in making a version of a spring type parting tool that he uses on his lathe, but making it for a BXA type tool holder. Now I said I would, but you might say, well, how come you've already got some? Well, this is an insert style and I use this because, well, you can swap out the inserts very quickly. This is a 2mm wide one. I've also got a 3mm wide one. This is an inverted style parting tool holder made by Eccentric Engineering here in Australia. Now I think they actually discontinued this particular one. They do make another one now called an FOR style, which means front or rear. And you can use it either conventionally with the cutting edge on top, or you can flip it over and use it with the cutting edge on the underside. Now, this one is very good. It has the advantage of lifting the tip of the tool if there's any chance of a dig in, and it will always lift away from the center line of the stock. The downside with this one here is that you need to run the lathe in reverse in order to use it. Now if you have a screw on chuck, that makes it problematic. My lathe actually has a keyed chuck, so it's not a problem. But some time ago I also made this one. Now this is a solid tool post that fits on the rear of the cross slide of the Colchester and it uses a T-type parting blade and it's great. It rarely gives me any trouble. I've had a couple of occasions when it's rubbed on aluminium just simply because I didn't use enough coolant, but on steel, stainless steel, brass, it's perfect. I don't have a problem with it at all. But it gets in the way sometimes if you want to fit some accessories to the lathe. Sometimes it's sort of in the way. So I thought I'd have a go at making this one that Mark has designed. Now Mark very kindly sent me this particular blade here and he also sent me some stickers which are up on the door right now. And in this type of parting tool blade, the cutting edge is actually wider than the underside of the blade. So this one here is 3/32 of an inch wide on the cutting edge, but it's considerably narrower underneath. So there's not a chance that the bottom edge of the parting tool is going to rub on the work. It also has a shallow groove running down the center of the top of the cutting edge. And that gives it a sort of a spoon-shaped cutting edge, which helps to roll the chip and make it smaller than the width of the cut that you're trying to create. So these are a particularly good type of blade, but I found them really hard to get here in Australia in this particular size. So Mark sent me one to have a go at using on this particular build. Now, in terms of materials, what do you actually need? Well, basically 3 pieces of steel stock. That's all you need. And this particular piece here, this chunk fits on top of the actual tool holder, the quick change tool holder. This part here holds the blade, and it'll be fitted more or less like that. 2 parts fit together that way and they're held together with 2 cap head screws. Now I was getting all geared up to actually show the build and then a gentleman in New Zealand named John Pierce made one of these. He actually got the plans that Mark had made and he made a version and he did a very good build video on it. So instead of me recreating that and doing it all over again, I'm simply going to point you in the direction of John's video, which is very good, and you can have a look at his build and exactly how he went about the process. So what I'm going to do is just go ahead and make this tool holder, and then when I've got it finished, we'll actually test it on the lathe. And I want to run some tests, both simulated in a CAD environment, but also do some real world testing with an indicator to see what sort of deflection we get when we do a cut on the lathe. Okay, so I'm going to head off, I'm going to make this thing, and I'll bring you back when it's all done, and then we'll have a go at testing it out on the lathe. No one will ever know. That little part you saw me just making there is the clamping washer that holds the blade in place in this blade carrier. Now this is a bit of a change from the one that Mark Winquist designed. I've added this little raised section here, this raised projection, and that will clamp against the surface of the blade just here. Now in my version, the surface of the blade is just very slightly below this bottom surface of the blade carrier here. Now that could be a machining mistake. I do know that this blade is very slightly tapered on this bottom edge here. So from this point below the thickest part of the blade down to the bottom there is very slightly tapered. So in my version, if you put that projection against the blade and then spin the screw down, and when it's almost tight, you can rotate that washer and you'll feel that little projection against the surface of the blade. So you put it about midway and then tighten it down hard. Alright, so that blade is locked in really hard now, and there's no chance that can slip laterally. And the other change that I've made in my design here is this little height adjustment bracket here. On Mark's design he had welded either side there, but I don't have a TIG welder and I wasn't game to try that with a MIG welder. I'd just burn it up. So I put a single button head screw on top there, and that's fitted into a pocket, so it's not going to go anywhere. And this is our height adjustment screw. Now also on the BXA version, this little bracket here is a lot shorter, and the screw center for the height adjustment is very close to this hold down screw, but for the BXA version I had to extend that. Alrighty, so this is actually ready to test out now. Now later on I'm going to parkerize all of these bright steel parts, but just for now we'll give it a try. But before I do that, I want to show you a sort of a 2D animation of what actually happens when the load goes on the tool. And then I've also got a CAD model which shows a simulation of the forces on the tip of the tool. So let's have a look at those. Okay, this is a 2D representation of the most important parts of this parting tool setup. So this grey section you can see here is the parting tool blade. The orange part is the blade carrier, and this circle here is the relief hole that allows for the bottom half of the blade carrier to flex. Now I've indicated what I think is the center part of the flexure with that red and white circle there. Now I just had to guess. I'm guessing that that's roughly where it's going to be. And you'll notice here that the tip of the parting tool blade is exactly on the center line of the axis of the lathe. Now the big yellow circle around the outside there represents the extreme diameter of the stock, and the smaller grey circle in the center represents the uncut material. And you'll notice that the blade is part way through the cut at this stage. Now I'm going to try to simulate what would happen if the tip of the tool were to dig in. So I'm going to take this part here and we're going to rotate that very slightly. You'll notice the gap at the back of the relief hole is now closed up, but let's zoom in and have a look at what's happened at the tip of the tool. Now you'll notice that the tool tip is now below the center line of the lathe, but crucially it's also moved back away from the cut surface. So it's that self-limiting process that helps these spring type parting tools from digging in, and also helps to limit the amount of chatter that you get. So that's the theory. Now, does that work out in practice? Well, I guess you could simulate this till the cows come home, but you really got to actually try it out on the lathe. But just before we do that, I want to show you another simulation that I did in Autodesk Inventor, and it represents what happens not only to the blade carrier, but also the blade. So let's have a close look at that. Okay, here are the same two parts we looked at in the previous 2D animation, but this is using Autodesk Inventor's stress analysis module. Now that golden coloured arrow that you can see at the top left hand corner of the cutting tool is a force of 100 newtons, or roughly 10 kilos. Now I just had to guess how much load was being applied there. I don't really have a way of measuring that. But you notice that the animation backs up what we saw in the previous 2D animation. Now Autodesk Inventor has a number of tools that allow you to visualize this from different viewpoints, and it also has tools that allow you to exaggerate the amount of deflection. Now in this particular view here it's doubled, but if I put it back to a one-to-one representation, you'll notice that it's nowhere near as pronounced what we're looking at previously. So you can see the colours representing where the forces are applied internally in the parts. But yeah, it sort of backs up what we saw, but I guess what we really need to do now is actually go and try it out on the lathe, and hopefully we don't smash up Mark's beautiful blade that he sent me. Now I got all excited yesterday and I was doing some parkerizing, so I did 3 of the parts of this tool and completely overlooked this clamp washer here. So old dumbass got carried away and forgot to check the bench. But if this proves to be successful, I'll do that at another parkerizing session. But looks nice, and I thought I'd show you before I destroy it. Now the next step is to set the tip of the parting tool blade to the correct center height of the lathe. So I'm going to use my tool setting gauge here, and you wouldn't believe the criticism I got when I made this, and I did a video series on it, and ever so many people told me that it was over-engineered, it was overbuilt, it was more complex than it needed to be, and that you could achieve the same result by trapping a steel blade or a steel rule between the tip of the tool and the workpiece, as if I didn't know that. But you know what? I love this tool. It's quick and effective. You can set tools in the conventional position or inverted position, and you just watch the little bubble there, and when you're satisfied you got that right, you can lock it all down. So that's all good to go. I have actually got a lock nut underneath this screw here, but I won't set that yet. Now I've got some stock set up in the chuck, so I'll do a sample cut and I'll just cut it and just see how it goes, and then we might put a gauge on it, like a dial indicator on it, and see how much deflection we're getting. But I'll try it first. If I destroy it, there's no point in going any further. This material here is some 32mm or 1.25" diameter free cutting mild steel. Now I've got a supply of this stuff and I keep it separate from all my other steel because I actually bought this many years ago, and I just keep it for these sort of jobs where you want a nice, easy to machine free cutting mild steel. Nearly everything else in my shop is unknown origin. It's just scrap bin material. I don't know the composition of it, so it's a bit of a lucky dip sometimes when you pull something out of the scrap box. We'll see how this goes. I'm going to run some coolant on this, and I'm running the lathe at 315 RPM, and I'm going to use power feed. So let's see what happens. Alright, that was fairly trouble-free. I could see right toward the center of the cut that the cut was becoming intermittent, like the chip formation was intermittent. And it could be that toward the center of the cut with the lower surface speed that the tool tip was springing back, and that was regulating the tool depth of cut. There's the piece that came off, and I've just noticed that this has got quite a prominent conical face on it, so it's nowhere near flat. And what I forgot to do was to lock the saddle down so that as the cut has progressed, the tool has migrated away from the cut surface, and that's the result. So So I'll do this again, but I'll lock the saddle this time and see if we get a different result. Oh, definitely got a different result. Don't know if you noticed, but that dug in, and the cut surface there now still has a very slight conical face on it. So what am I doing wrong? Something is moving. So it could be something to do with the alignment of the putting tool blade itself. I'm going to have to run some checks on this, but what happened, well, you would have noticed it, that it dug in. I stopped the automatic feed and I finish it off by hand feeding, and that allows you to sort of just feel what's going on, and you sort of feel or sense when it's about to get overloaded on the tip of the tool. So the tool is obviously flexing within the cut, and I don't have a great deal of stick out on that. It's probably about 25 millimeters, but yeah, that's not the sort of behaviour you want to see. Alright, I was just looking for answers here, and one thing I didn't do when I reassembled the actual tool holder was to check the alignment of the parting tool blade. So I put an indicator against the side of the blade there, and you can see it's a long way out. So that should be reading 0 as I move the tool in the x-axis. Now I didn't change the position of this tool post here. That was still set square to the lathe, but obviously something went wrong when I reassembled the tool holder itself. So I'm going to fix that. Alright, what I ended up doing was loosening off these 3 cap screws here and tapping this block on the top here, and I've got that to within about 1 thou over the full length of the blade, or the cutting length anyway. So I'll run another test now. Alright, still not right, but you know what, I forgot to lock the saddle again. Come on Mark, get her together. Still not right, it's still moving. So the center of this part here is hollow, which is really weird. Alright, you know what, I'm going to stop here. I need to get some guidance on this. So let me take the tool out of the lathe, we'll have another look at it. If I can't get the blade to stay perpendicular to the x-axis of the lathe, it's a waste of time sort of looking at any other testing on this. So I'm going to get in touch with John and Mark and see if they've got any advice for me. But it's a bit of a mystery at this point. Let me go over to the bench and we'll talk about where we go with this next. Well, this is not how this video was meant to end. I was sort of hoping I could show you lots and lots of these beautifully machined discs on all different diameters and different materials, but clearly that's not happening, so I don't think there's any point persisting until I can diagnose what the problem is with this. Now, if you think you know what I'm doing wrong, please let me know in the comments, but just a couple of things to consider. This is the BXA version of the tool that Mark designed, and the one that he uses quite successfully. And his is an AXA version, so physically it's smaller. Now the other thing is that this is the original blade that Mark sent me with the factory grind on it. I didn't mess with that. It's still sharp and it's not damaged. It's got about 25 millimeters of stick out, or 1 inch, which I think is sort of, I don't know, middle of the road. The other thing that might be a factor is that there is a gap between the back of this tool holder plate and the BXA tool holder body. Now I'm not sure in Mark's original design whether that was the case. Now my thinking was that you want this bottom section of the tool holder plate to be able to flex back freely without any friction between those two surfaces, between these two parts. Now it could be that by having that gap there, this whole bottom section is able to flex and twist, and maybe it does need some support from the BXA tool holder body. Now it's easy enough to fix, so I just need to machine some material off the surface here to get that right. But maybe that's a consideration. Now the thing is that it is actually producing beautifully tight curly chips, as you can see there. So I think you can see that. But on all of these cut-off discs here, you can see that there is quite a prominent scuff mark about 2/3 of the way, maybe halfway in, and that's where something was rubbing and catching. So until I can get that fixed, until I can get it to actually produce a clean machined face, I don't think there's any point in going any further. Now the other question is, am I going to use this cut-off tool or parting tool in preference to my rear parting tool holder with a solid tool post? Probably not. I think that rear tool post version, it works reliably. I've never had a problem with it. It's never dug in. I've never cracked or broken a blade. So it's preferable to me. There are some situations where this might work better. But like I say, until we can get that fixed, no point going any further. But I will do a follow-up. Now, if I resolve this and I get some advice from people, or from Mark or from John, who designed one this size, then I'll get back to you and let you know. But as a machining exercise, little machining job, I've enjoyed it. I think it's worked out really well in terms of fit and finish, but in terms of execution, I've got some work to do. Anyway, that's it for now. Thanks for watching. When we come back, I'm going to show you a different tool that I've designed for the lathe. It involves a bit of metal casting, some metal finishing, and I'll demonstrate how it works, but it's a cracker. But for now, this one, I've got to do some homework on this. Okay, thanks for watching. It's Prezzo. I'll see you next time. Cheers. Go on, be free. Don't look at me like that. Go and digest your meal.